Thank you very much indeed. Jeche kommen til þess að hressa ykkur við. Does that work? I hope that means I'm here to cheer you up. But I'm afraid from now on it's in English. So what I'm here to do is to give you some reasons to be cheerful on a bright, sunny Friday afternoon. And also to say it's not just that the world could go on getting better, but there are good reasons I now think, for understanding where prosperity comes from and how it's basically an inexorable evolutionary process. Now, this is a terrible time to be alive. You know, in Europe, things are pretty bleak, and they may get a lot bleaker still. I'm not here to deny the problems of the world. But Europe is not the world. The rest of the world has had a fantastic 5 years. Africa has seen its fastest economic growth for quite a while. So in the big picture, in the long run, there are reasons to think that the world has been getting better off and is going to go on doing so. Let me first of all just run through some numbers to try and persuade you how much better off you are than your grandparents. Here's world GDP per capita by two different measures over the last 400 years. How much goods and services the average individual has at his disposal. And if we extrapolate that to the end of this century, it's quite interesting to look where it's headed, according to these two measures. Now, that might not happen. There's all sorts of reasons why it may not go that way. But wouldn't it be rather wonderful if we could get that rich and do so without destroying the planet along the way? It's not just that the rich have been getting richer. The poor have been getting less poor. This is the number of people living on less than $1 a day, corrected for inflation. And as Pinkowski and Salah E. Martin have shown, it's been going down steadily for many years now. That's the number, not just the proportion. And even in Africa, a continent for which the 1980s and 1990s were not good decades, in which on the whole Africa went backwards, the 2000s have been a spectacular decade. And in fact, as I say, this graph only goes up to 2006 or so. After that, African economic growth has been even faster. So when an environmentalist, for example, like Jonathan Porritt, says it is blindingly obvious that completely unsustainable population growth in most of Africa will keep it permanently, hopelessly stuck in deepest, darkest poverty, I think we need to take that with a pinch of salt. But it's not just money, is it? I mean, money's not the only way of measuring how well off we are. In fact, time is the key ingredient. How long it takes you to fulfill your needs. That's what defines whether you're better off than your grandparents. Your needs and indeed your wishes. And so ask yourself a simple question like this one. How long do you have to work if you're on the average US wage to earn 1 hour of artificial light from a compact fluorescent bulb? An 18-watt compact fluorescent bulb burning for an hour is about 1,200 lumen hours, enough to read a couple of chapters of my book this evening, if you wish. And the answer is about half a second. That's how long you would... This is William Nordhaus's data. It goes back quite a way now. It's 15 years old. It's probably less than that now. But that's about how long you have to work to earn that much light. How long did your grandparents have to work to earn that much light from an incandescent bulb with the then cost of labor and the then cost of electricity? And the answer is about 8 seconds. So that's 7.5 seconds that you've got that your grandparents didn't have. And in those 7.5 seconds, you can fulfill another need. And that supplies someone else with another job. That is economic growth, I think, in the end, is the saving of time so that you can fulfill more needs. In 1880, you'd have had to work for 15 hours on the average American wage to earn that much light from a kerosene lamp. And in 1800, for 6 hours. The average person could not afford a candle in 1800. It's quite a remarkable story, this. Just to, light was once a luxury. It's now a necessity. And you can see how that's come about. So we're better off. But are we healthier, happier, cleverer, cleaner, kinder, freer, more peaceful, and more equal? And the answer is yes. We're healthier. We're living longer. Life expectancy at birth is up around 30% in my lifetime. We're happier. May not seem so if you read our newspapers and you listen to me or anyone else grumbling about things that are going wrong in the world, but there is a correlation between income and happiness. It's not a perfect correlation, and it's not a linear correlation, and it's perfectly possible to be very rich and very unhappy, but that cheers the rest of us up, so that's all right. But nonetheless, when it used to be thought that there was not a correlation, that James Eastlin claimed that above a certain level you actually got unhappier as you got richer. It's not actually true. You kind of level off, but you don't actually necessarily, on average, get unhappier. We're cleverer. Not just are we spending more years in education, but actually our IQs are going up. This is called the Flynn effect. It's happening all over the world. Nobody quite understands it. James Flynn himself has various ideas about what's causing it. But basically, it's a leveling up phenomenon, i.e. People are not getting childhood infections or childhood malnutritions that enable them that cause them to fail to achieve their potential, as it were, intellectually. So that's rather nice. We're cleaner. The world is the rivers and the air of most countries, particularly in the West, is much cleaner than it was. That's U.S. air pollutant emissions coming down. So when Life magazine said in 1970, by 1985, air pollution will have reduced the amount of sunlight reaching the Earth by half, they were wrong. It wasn't half. It was the other way around. More sunlight reached the Earth. I would argue that we're kinder too. This is simply UK data showing charitable donations compared to GDP, on the whole going up. This was before the recession. No doubt they've gone down again, but then so has the GDP. So, on the whole, people are, I think, more generous. We're freer. More people, this is the freedom in the world country rankings. More people live in countries that can be described as free than in countries that can be described as non-free. This data comes before the Arab Spring. We hope that the Arab Spring will cause 2 or 3 countries to move from the red line to the green line. We are more peaceful. Your chances of being a victim of homicide in Europe are dramatically lower than they were in the Middle Ages, which is good. And did you know that the 2000s was the decade with the least number of deaths in warfare since records began? I mean, obviously this graph goes up and down, and the 1940s were a horrible blip, and the data doesn't actually go back earlier than that. So you might argue that there were some 19th century decades with fewer deaths in warfare, but still it's rather amazing that we've just had the most peaceful decade we can think of. Now, it didn't feel like that in Britain because of Iraq and Afghanistan. And it wasn't true for Britain. We had more warfare deaths than we had in the 1990s. But for the world as a whole, that was true. And we are more equal. The Gini coefficient of global inequality has been going down. And the reason for that is because poor countries have been getting rich faster than rich countries have been getting rich on the whole over the last 20 years. And so although inequality has been going up within poor countries and within rich countries, nonetheless global inequality has been going down. People are converging on the graphs which used to have the rich first world and the poor third world are kind of merging. And of course the recession has accelerated this because Africans are getting rich quite fast, whereas Europeans are not getting rich at all. So my argument is, how is this possible? I'm coming at this as a scientist, as a sort of biologist, saying, well, what is this thing called prosperity? Why does it happen to us and not to rabbits or rocks? Where does it come from? And talking of rocks, what sort of kicked this off in my head one day was this object, which sits on my desk at home. It's an Ashwalian hand axe from about 500,000 years ago, of the kind used by Homo erectus to slice up rhinoceroses or whatever. And right next to it, I suddenly noticed one day, there is an object of exactly the same size and shape, both designed to fit the human hand. So that's why they're the same size and shape. But in those two objects is the whole history of humanity. We've gone from that to that. And we still need something that fits the human hand, but we've changed dramatically what it is. And the key difference between those two objects for me Well, I'll come to several differences, but I think sort of the first insight is that the one on the left is made from a single substance and embodies a single idea, which is slicing rhino hide or whatever it might be. The one on the right is made from lots of different substances, plastic and silicon and metal and so on, and embodies lots of different ideas. Ideas that occurred to people who are now dead, ideas that occurred to people who are thousands of miles away, but they're all embodied in that, the idea of the laser, the idea of computing, the idea of silicon, the idea of plastic. These are all different ideas which came together in that one object. And I would argue that that is the secret of what human beings achieve, is that essentially we bring together ideas and combine and recombine them. Because in going from making simple tools to making sophisticated high technology, we've obviously changed ourselves, and we tend to think this is because we have culture, because we're uniquely able to teach each other how to do things, and these habits get passed on. But it's not true, is it? Because lots of other animals have culture. Chimpanzees have culture. They teach each other how to crack nuts with rocks. Crows teach each other things. Mammals in the sea do it as well, killer whales, things like that. So it's clearly possible for other animals to have culture. I would argue that there's something peculiar about human culture that has triggered this, and that's the fact that we exchange. We swap goods, we swap objects, we swap ideas, we swap services. And that this is actually the ingredient that kicked off humanity's explosion from being just another brainy cultural animal to being suddenly a high-tech creature that dominates the planet. And essentially the argument it was put a long time ago by Adam Smith that exchange is unique to human beings. No man ever saw a dog make fair and deliberate exchange of a bone with another dog. This is a uniquely human feature. No other creature swaps different objects at the same time among strangers. You can get swapping of you scratch my back, I scratch yours, of the same service at different times in other animals, and you can get the swapping of objects between close kin, but you don't get it among strangers. And I think it had a profound impact on human history. Because in a nutshell, it led to, well, why does exchange lead to time saving, which is, remember, what I think prosperity is? It all, in a sense, boils down to this idea, comparative advantage. The law of comparative advantage, as described by David Ricardo, has been described as the only proposition in the whole of social science that is both true and surprising, which is unfair, but it's a nice joke. And here's a Stone Age version of the story. You have two guys sitting around the campfire hundreds of thousands of years ago called Adam and Oz. Adam takes 4 hours to make a spear and 3 hours to make an axe. Oz takes 1 hour to make a spear and 2 hours to make an axe. So Oz is better than Adam at both spears and axes. So Oz doesn't need Adam. Adam is a waste of space. Well, no, because if Oz were to make 2 spears and Adam were to make 2 axes, and then they were to trade, they would each have saved an hour of work. Because Oz would have worked for 2 hours instead of 3, and Adam would have worked for 6 hours instead of 7. So they're both better off. Now, this is only true because Oz is better at making spears and Adam is better at making axes. But then if they start specializing and exchanging, that's going to be true. That's going to become more and more true. This is a kind of fast breeder reactor. The more you do of it, the more benefit you get out of it. The more you specialize, the more benefit there is in exchange. The more you exchange, the more benefit there is in specialization. And I think that the kicking off of that fast breeder reactor is the great story of humanity. Because if you go back to these 2 objects for a second and ask yourself, who made them? And the answer is that the man who used the stone axe made it for himself. We kind of know this from the archaeological evidence. You can see where they were made on site by people sitting around making their own hand axes. The one on the right is mine, my mouse, but I did not make it. It was made for me by hundreds, thousands, possibly even millions of people when you think about it, because there was a man growing coffee in Brazil that was going to be drunk by a man on an oil rig who was drilling for oil, whose oil was going to be used to make plastic in a refinery, and the plastic was going to end up in the... They were all part of this project to make me a computer mouse. They were all working for me. They were my servants. And the way you got rich in the old days was by having a lot of servants. And I would argue that that's kind of the way the world works now, is that we are all each other's servants. We're all working for each other. Louis XIV had 498 people to prepare his dinner every night. But do you know what? Each of you has 498 people to prepare your dinner tonight. I may be wrong, but I bet there's 498 cooks or chefs within an hour of this lecture theatre who could provide you with excellent meals. And you can choose which one you go to. They're all ready to work for you tonight. What's the difference between that and having 498 chefs in your own kitchen? Well, one difference is the food will be better here than it was for Louis XIV. Talking of kings, there's an interesting parallel with what human beings have achieved in the animal world, and this is where I come back to my evolutionary biology, which is that, of course, we do get sophisticated societies within, for example, the social insects, like the ants and bees and so on. What's the difference between what they do and what we do? Because they get specialization, they get division of labor between workers and queens and workers and soldiers and things like that. And here's a worker ant feeding a queen ant. And the big difference is that you get this kind of division of labor only within the family. Because an ant colony in the end is just a big family. It's a great big kin network. Everybody's related to the queen. That's the whole point of the colony. And this is because they have one kind of division of labor that we don't have. The reproductive division of labor. That is to say, they delegate reproduction to a specialized caste, the queen. We don't do that. It's the one thing we rather like to do for ourselves. Even in England, we don't expect the Queen to do it for us. So when did we start swapping things? When did we start this habit of exchange? I've no idea, and the evidence is not great, but I'm going to run through a couple of points. The one is that we might have got into the habit of this because of our habit of the sexual division of labour. In all hunter-gatherer societies that are known on the planet today, there's a sexual division of labour with respect to foraging. That is to say, on the whole, men hunt and women gather. It isn't quite that simple in some societies, and it isn't always meat versus vegetables, but nonetheless, and then they swap, and then they exchange. And it's a brilliant system, because what it means, here's an example from the Hadza in Tanzania, who are hunter-gatherers, that the men go out hunting for warthogs and the women go digging for roots. And of course, what that means is that both sides of this exchange are better off, because the men know that if they fail to catch a warthog, there's still going to be some carbohydrates for dinner. And the women know that in order to get protein, they don't have to go out on an exhausting and dangerous hunt. They simply have to make sure they've dug up enough roots to be able to swap some for meat when the men are successful. So economically, it's a first example of a gain from trade, and it's a characteristic human feature. And when you think about it, agriculture was, again, working for each other, that we simply extended this beyond the species. So in this picture, there's a shepherd with a sheep and a dog. The sheep are working for the dog, and the dog is working for the man, and the man is working for the dog, and they're all working for each other when you think about it. That's kind of what agriculture is different species working for each other. But when did we first start swapping objects, in the archaeological record? And the answer, I think, is about 120,000 years ago. That's when you first start picking up manufactured objects moving long distances. Until that point, things are always found very close to their source of manufacturer. But these beads found in Algeria, for example, which have been made from snail shells, and the snails are found in the Mediterranean, but these beads are up to 100 miles inland. And we know from looking at modern Aborigines in Australia that you simply don't find manufactured objects moving long distances except through trade. It doesn't happen through migration, it happens through trade. And you don't see this before about 120,000 years ago. And you start to see it in volcanic glass objects in Ethiopia, and then, as I say, in these snail shells in Algeria. The Neanderthals, who lived until about 30,000 years ago and had very big brains, on average slightly bigger than ours today, never did this. That is to say, they only ever used local materials. This is an example of a cave in the Caucasus where there are modern human remains, and very close by there are Neanderthal remains. And the difference is very striking. The Neanderthal tools are all made from local stone. The modern human tools are made from stone that comes from, in some cases, hundreds of miles away. And when you think about it, this shows that the invention of exchange had a dramatic impact on innovation, because it means that an idea or a new material can travel, you can get it from elsewhere. You don't have to invent it yourself. You can get it from another part of your species. You can get it from a long way away. You're drawing upon the inventive power of not just your local band, but of the whole species. Now, this is where I was very struck by a parallel with evolutionary biology. And as Ragnar said, I wrote a book about the evolution of sex. And I suddenly realized that there's a very close parallel here between the way sex works and the way exchange works. Because in biology, cumulative evolution cannot happen without sex. Because here's an example. There's an asexual population evolving along. Oh, sorry, I jumped ahead there. A green mutation arises and a red mutation in different lineages. And one is better than the other, so the other has to go extinct. You can't inherit both if the species is asexual. If the species is sexual, then at some point an individual can get both the green mutation and the red mutation, so it can combine the two. It enables you to draw upon any genetic innovation that happens anywhere in your species. You don't have to be confined to your own lineage. And I think exchange has the same impact on culture, that it enables you to suddenly pick up an invention from wherever it happens in the human race. You don't have to just invent it locally. And when you think about it, most innovation takes the form of combining two different ideas so as to make a third one, so as to breed a third idea, as it were. My favorite example is the pill camera, which takes a picture of your insides on the way through. It came about after a conversation between a gastroenterologist and a guided missile designer. What happens when you cut people off from exchange networks? And the answer is that you not only suppress their innovation rate, you can actually put it into reverse. And a very good example of this comes from ancient Tasmania. Tasmania became an island about 10,000 years ago when rising sea levels cut it off from Australia. And the people who lived on Tasmania after 10,000 years ago were totally isolated. They had no contact with the mainland after that time. And what happened was not only did they fail to pick up innovations that happened anywhere else in Australia, like the boomerang, which was invented after 10,000 years ago, but they actually gave up some of the innovations they already had. They gave up bone tools altogether, for example. And the reason for this seems to be, according to an anthropologist called Joe Henrich, that there was simply too small a population to keep alive the specialization and exchange that you need to keep alive these technologies. About 4,000 people living on the island. If the 4,000 of us were suddenly dumped on an island, how many skills would we be left with? Many fewer than we have, as it were, today. So rather remarkably, it seems if you isolate people from exchange, you can not only lower their innovation rate, you can put it into reverse. The same did not happen on Tierra del Fuego, a similar island, just as inhospitable, but with one big difference, which is that the Indians who lived on Tierra del Fuego were in trading contact with South America throughout the last 10,000 years, because the Magellan Strait is quite narrow, whereas the Bass Strait is quite wide. So the Fuegians, for example, got the bow and arrow from other places. There's been a very nice test of this idea that exchange and trade drives innovation in terms of measuring fishing tackle, analyzing fishing tackle from the Pacific Ocean from before Western contact. And it turns out that islands with big populations have slightly more sophisticated fishing tackle, but islands, even with quite small populations, can have sophisticated fishing tackle if there's exchange between the islands. In other words, if islands are well connected by trade networks, then they tended to have more sophisticated fishing tackle than their size would predict, which is really nice little demonstration of this point. So go back to this image one more time and ask yourself not just who made the mouse for me, but who knew how to make it? And the answer is nobody. I'm, of course, quoting a famous essay by Leonard Read, the economist. Hayek made this point. Friedman used to make this point as well, that there is no human being on the planet who knows how to make a pencil. Because the man who runs the pencil company doesn't know how to make it. He just knows how to run a company. The man working on the assembly line doesn't know because he doesn't know how to chop down a tree. And the man chopping down the tree doesn't know because he doesn't know how to mine graphite and so on. The knowledge is not held by any individual. And this is true of every object we use in the world, is that it's held by a collective brain, not by an individual brain. And that's why I think that there is very good reason to believe that we have a bright future, because we just got an awful lot better at exchanging and swapping ideas. Here is a collective brain. It's called the internet. And there are many, many different... We are the nodes in this collective brain. We are the neurons. But we're not the brain. We're the neurons. Now, that's the first half of my talk about where prosperity came from and why. And I now want to try and persuade you that this can go on, that the future need not be bleak, that we're not going to run into all sorts of constraints. So I'm going to go all ecological for a while and try and persuade you of that proposition. In my lifetime, the world population has roughly doubled, so we're at 7 billion people now. And yet, during that period, on every single continent, the amount of food available per capita has gone up. Which is rather remarkable. And at the same time, we've actually, in large parts of the world, returned a lot of land to nature. This is a stone wall that used to run between two fields in New England. It now runs through woods. New England is 70% woodland, whereas it was once 70% farmland. The same is true of Britain and Italy. Britain has now roughly the forest cover that it had at the time of William the Conqueror, 3 times as much as it had 100 years ago. So we're returning land to nature, not in all parts of the world, not in a lot of tropical countries, but in a lot of the West, we're returning quite a lot of land to nature at the same time as we're feeding a larger population. And that problem the problem of feeding people should get a little bit easier, because the rate of growth of world population is falling. It's half of what it was earlier in the century, in the 1960s. It looks like it's going to hit 9 billion in 2050 and possibly 10 billion by the end of the century. It might go higher, it might go lower. But how much land do we actually need to feed 9 billion people? Well, currently we crop about 15 million square kilometers, which is about the size of Russia. If we were to add 2 billion people to get to 9 billion, we're going to need more land. If we wanted to feed them organically with the lower yields that are inevitable if you're not using synthetic fertilizer made from the air, then we're going to need an awful lot more land still. And it's been calculated that we would need, to feed today's population, we'd need roughly twice as many acres of farmland as we do actually plough if we weren't using synthetic fertilizer. So let's abandon that idea. And if we were to treble yields from here, if we were to get every field to yield 3 times, or on average, the average field to yield 3 times as much, we would actually be able to feed 9 billion people from a smaller acreage than we currently feed 7 billion from. Could that be done? Sounds a tall order, but it's actually what we've done in the last 60 years. We've trebled the yields of rice, wheat, and maize, which provide about 60% of our calories, while increasing the land acreage devoted to these crops not at all. In fact, there's been a slight decrease. We were told throughout this process by environmentalists that it couldn't be done. Here's an example. Lester Brown in 1974 saying farmers can no longer keep up with rising demand for food and famine is inevitable. Can it be done again? Well, I would say, yes, it probably can, because just look at this chart. This shows the the yields that we get in different parts of the world. And East Asia Pacific has had dramatic improvements in yields over the last 50 years, whereas there's been hardly any change at all in sub-Saharan Africa. So all we need to do is get synthetic fertilizer to sub-Saharan Africa, and we would make a great leap forward in the amount of yields we could achieve for feeding people, let alone new technologies like GM crops and so on. And meanwhile, we're moving to cities. And cities, on the whole, are more efficient things to live in. We tend to use less energy, less space, less resources in cities. And the number of people living in rural areas is probably now falling, which is rather remarkable when you think about it. So in going from a primitive, low-tech lifestyle, we've actually shrunk our impact on the planet in many ways. A hunter-gatherer needs about 1,000 hectares per head to support his lifestyle on average throughout the world. Slash-and-burn farmers need about 10 hectares. The 1950s agriculture, we needed about 4,000 square meters. And recently, we're probably down to about 1,000 square meters is all you need to support a human being today. At the theoretical limit, if you could get maximum photosynthesis in an Icelandic greenhouse and feed people from that, is about 27 square meters per person. So there's a long way to go yet before we're at maximum efficiency. And there's a wonderful calculation by an ecologist called Helmut Habel in Vienna called HANP, Human Appropriation of Net Primary Production. In other words, how much of the world's vegetation do we grab for ourselves and our pets, like cows and sheep and so on? And the answer is we still leave about 3/4 of the greenery that grows on Earth to nature. We consume about 14%, and about another 11% is destroyed or prevented from growing by concreting it over or having too many goats grazing the wilderness or something like that. And some of what we consume then, some of what we grow then goes back to nature. But the fascinating thing that Habel finds, I think, is that there are parts of the world where human appropriation is less than human impact on production. In other words, that by adding fertilizer or irrigation, we actually increase the amount of greenery produced on the from each acre of land, more than we then pinch for our own needs. So actually we end up with as much left over for nature as if we weren't here at all. They're the blue bits on the graph, so there's not very much of them yet. But for example, in the Nile Delta, we're stealing a lot of energy for ourselves, but we're actually creating so much energy that wouldn't be there if it wasn't for human irrigation, that we're leaving even more for nature than if we weren't there. What about resources? What about running out of metals and energy and all these other things? I mean, this was a book that I believed when I was a student. I believed all these people who said that the population explosion was unstoppable, the oil was running out, a cancer epidemic caused by chemicals in the environment was going to shorten my lifetime, my sperm counts were going to fall, all this kind of thing. And this was the publisher's summary of what's in The Limits to Growth, which came out 40 years ago this year. Will this be the world that your grandchildren will thank you for? A world where industrial production has sunk to zero, where population has suffered a catastrophic decline, where the air, sea and land are polluted beyond redemption, where civilization is a distant memory. This is the world that the computer forecasts. I love that, the computer. There was only one in those days. And yet what happened? The price of metals went on down. It has blips, it comes up and down, but basically it's extraordinary how cheap most metals are. And although textbooks have said that metals are running out for years, it just simply isn't true. We're finding, as if prices go up, you find new sources, etc., etc. Most minerals are more abundant now than they were in the 1970s. And very strikingly, in terms of fossil fuels, it isn't, to me, immediately obvious that the use of fossil fuels is a bad thing for the environment. Here, if you can see it, you may not be able to see it very clearly, is a satellite photograph and an aerial photograph of the Haitian-Dominican Republic border. Haiti is brown on the left and Dominican Republic is green on the right. What's the difference? The difference is that Haiti lives entirely on renewable energy, that is to say wood, which is used not only for cooking in the form of charcoal, but also for running industry. As a result, it is 98% deforested. Whereas in the Dominican Republic, propane for use as a cooking gas is subsidized. And it's subsidized deliberately to take pressure off the forest. So it seems to me that by using fossil fuels, we've done an extraordinary, we've released the need to put pressure on forests in particular. But aren't fossil fuels going to run out? Well, I don't think so in any meaningful or practical sense. Here's the amount of fossil fuels that we've consumed compared with, on the far right, how much we know is in the crust of the Earth. Now, an awful lot of that's not accessible, and the blue stuff, the methane clathrates on the ocean floor, are in theory a gigantic resource, but nobody's yet figured out how to turn them into an energy source. Japanese are onto the case, though, so I wouldn't bet against it. But you know, we do keep turning inaccessible energy sources into accessible ones. Shale gas is the classic example. That's the green stuff on that chart. Until 10 or 20 years ago, nobody had the foggiest idea how to get gas out of shale. Now it's had a dramatic effect just in the last 5 years on American energy consumption. It's driving coal out of the electricity market at a very rapid rate. It's about to start driving gasoline out of the transport market to some extent. It's never going to completely replace it, but you will see natural gas vehicles multiplying everywhere. And rather dramatically, it's caused a sudden drop in carbon emissions by the US economy, largely because of shale gas. So I'm not convinced that land is going to run out. I'm not convinced that metals are going to run out. I'm not convinced that fossil fuels are going to run out in any meaningful sense in this century. Sure, some of the cheaper oil fields will run dry, and we may be left with the more expensive sources of oil and things like that. But it's amazing what price does to bring on innovation and find other ways of substituting. What about climate change? Well, climate is changing. I have absolutely no doubts about that, and I'm pretty sure human carbon dioxide emissions are responsible to some extent at least. But we've got to face the fact that this phenomenon is happening more slowly than predicted, not faster than predicted. Here are two measures of what's happened to the global average climate over the last 30 years, one from satellites, one from surface temperatures, and they're both now below the lowest line predicted by the Intergovernmental Panel on Climate Change in 1990, even though carbon emissions are higher than in the highest line predicted at that time. Now, this might be a temporary pause and it might resume, but it is a fact that it is not happening that fast at the moment. Sea level was supposed to accelerate upwards. If anything, it's showing a deceleration at the moment. And what is happening is actually not necessarily inconsistent with theory, because the alarming version of climate change is this, that you get your 1.1 degrees of warming out of a doubling of carbon dioxide. Virtually nobody disagrees with that. That's what the Intergovernmental Panel on Climate Change has a consensus about, that's all you get from doubling carbon dioxide alone, but that is amplified by the extra water vapor in the atmosphere, which then trebles the effect. Because of warming up the air, the sea a bit gets you more water vapor in the atmosphere, and so on. But a lot of other scientists say, well, hang on, we should be seeing all sorts of signs of this amplification effect going on, like a tropical troposphere hotspot, an increase in humidity in the atmosphere, etc. And we're not seeing that because humidity in the atmosphere has this funny habit of causing clouds, and that not only cools down the Earth, but it also precipitates out as rain. And so a lot of other people think that, yes, you get your full carbon dioxide warming effect, but that actually you might even get a dampening effect from the extra water vapor in the atmosphere turning to clouds. And we're bang on the line of zero feedback, of zero amplification. We've had about 0.6 of a degree since we started seriously changing the atmosphere, which is roughly where what we would expect if we're on course to have about 1 degree of warming by the end of this century. We're not on the line where the Intergovernmental Panel on Climate Change has predicted, because if we were going to have 3 degrees by the end of this century, we should have had 1.5 by now, because the curve is logarithmic. And even as climate changes, we're not a sitting target. We don't just sit still and wait for these things to happen to us. We adapt. Here's a marvellous example. This is the number of deaths from extreme weather. That is to say, from droughts, floods and storms over the last most 3/4 of a century or so. And you can see that not only the number of deaths, but the probability of dying is down by over 90% during that time. This is it's 98% fall in your probability of dying. This isn't because the weather's got less dangerous. This is because people have better transport and better communications and better shelter and better warning and all these other things. In other words, technology enables us to adapt to climate change. Malaria is another good example. In 1900, malaria was found in all sorts of pretty cool parts of the world, like Russia and North America. By 2007, it had retreated from most of those places. It was only really a problem in Central Africa and a few parts of Southeast Asia and Latin America. The change shown in blue at the bottom is a decrease everywhere. That wasn't because the world got cooler and less congenial to mosquitoes. The world got warmer during that period. It was because we moved indoors and shut the windows and used DDT and drained the swamps and took malaria pills and all these many, many things that we continue to do. Malaria mortality is down 25% in the last 10 years alone. We are seeing a collapse. If you're a plasmodium parasite, these are bad, bad times. So I asked myself that if the disease of global warming isn't as bad as people say, is the cure worse than people say? I mean, why are we using the landscape to make energy? Why are we using biofuels and solar power and wind and hydro and all these things when we could just get the energy from an underground rock? I'm not necessarily referring to geothermal, although that'd be great too, obviously here, but I'm talking about coal and fuel and gas and oil, instead of slicing eagles up with wind power turbines. And why are we turning food into fuel? I mean, last year the world turned 5% of its grain crop into motor fuel last year. And it displaced 0.6% of oil use. So it had almost trivial effect on oil use, but it had a dramatic effect on food prices. And there's a calculation by Indo Goklani that it may have killed 190,000 people, because that's how many extra people were tipped into serious malnutrition by increases in the price of food. And it's putting pressure on the rainforest. So I'm not convinced that the cure for climate change isn't worse than the disease. To summarize, my argument is that as we get more technological, as we do more innovation, as we get richer, there is a chance of doing more for less. And that actually gives us a better chance of achieving sustainable development. And I'm very happy with this definition from Grohol and Brundtland of sustainable development. Development that meets the needs of the present without compromising the ability of future generations to meet their own needs. How best to get there? Well, if we're richer, we have fewer babies. We know that. That's clear all over the world. People, once their children stop dying of diseases, they have fewer of them. They stop planning for losing some. If we have higher farm yields, then we need to cut down less rainforest to grow our food. If we have new technology, we actually use less resources, things like optical fiber, replace copper and so on. And if we use more shale gas or something like that, we don't need to use the landscape to produce energy. Now, people sometimes say to me, if I try and persuade them to be a rational optimist, yes, but isn't pessimism necessary? Isn't it only because we worry about the problems that we set out to solve them? Isn't it only because we're scared stiff of what might happen that we innovate? And that sounds plausible for a while, but think about it. You know, who's driven by worry when they innovate? I mean, here are 6 great innovators: Archimedes, Al-Khwarizmi, Fibonacci, George Stephenson, Thomas Edison, Steve Jobs. What did they all have in common? Every single one lived at the richest spot on earth in his day. Ancient Greece, Abbasid Arabia, Renaissance Italy, Victorian England, New Jersey, and California. They weren't driven by worry about what was happening to the world. They were ambitious. They were trying to make a good world better rather than a bad world not so bad. Let me end with this quotation. We cannot absolutely prove that those are in error who say society has reached a turning point, that we have seen our best days. But so said all who came before us, and with just as much apparent reason. On what principle is it that with nothing but improvement behind us, we are to expect nothing but deterioration before us? Well, that wasn't me or someone like me. That was Thomas Babington Macaulay, the historian, in 1830. Already then he was fed up with the pessimists saying things can't get better, they can only get worse. And think how much better they got since those days. So my argument in a nutshell is that going from the individual intelligence that enabled us to make objects like this to the collective intelligence embodied in an object like this, we've given ourselves a bright future, as long as we don't make a frightful mess of it. Thank you.